So I got into photography recently, and there is this thing in photography called the bokeh effect, and I got really interested in the effect. Here is an example on your screen right now. You see what I'm talking about. The subject is in focus while the background is all blurred out. Here's a photo without the effect. People use this to create all sorts of crazy effects in their photos. Portrait photos especially benefit a lot from a blurred background, because then all the attention of the viewer is diverted towards the subject. It also looks just really cool. This is why phone cameras that cannot produce this effect naturally use all sorts of software magic to recreate the same effect, and they call it the portrait mode. On a more full-scale camera though, like a DSLR, this effect can be produced naturally by exploiting the optics of the camera. If you look up online, you will find a lot of resources on how to best use this effect and what lenses to buy that have the best bokeh. But not all of them will tell you how it actually happens. I'm going to try and demonstrate that using this physics simulator. So on a DSLR, there are three main things that the photographer can control to get the picture and get the desired result. The first is the shutter speed. This is basically the amount of time for which the camera is capturing light. The second is the ISO speed. This is the sensitivity of the camera. And the last is the aperture. This is what controls the bokeh effect, and this is the opening through which the camera lets in light onto the sensor. Now before we get to how the aperture controls the bokeh effect, we first need to focus on what is going on here. And what is going on here is that things are out of focus in the frame, and we need to know why. So let's understand focus first. This point source of light will be in focus on this screen here if all the rays coming from that point after refracting from our lens converge to one point on this screen. Now if we move the screen back and forth, you can see that right there we can see a position where most of the rays are falling onto this one point here. Now there are rays that are not falling on that point, but that is due to some optical aberrations in our lens. As it is, this point is now in focus on this screen. Now when I move the screen away from this position, you can see that the rays of light are now falling on a much bigger area. This is basically how the bokeh effect occurs. Rays from a point source of light are now falling on a much bigger area, forming those big circles of light that we can see in the example. Now where does the aperture come in? The aperture is only there to control this effect. I've got an aperture right here. So if you drag this aperture over into our camera, I'm going to put it right there. Now, say close this aperture so small that only one ray of light can escape from it. There. Now where's the point of focus? Well, if we move the screen, we can see that no matter where the screen is, the rays are always falling on just one point on the screen. That means that the point is in focus everywhere. Now of course this is theoretical, no one can close the aperture to be so small, but even as an approximation this explanation works, because for a small number of rays the object stays relatively in focus. This is essentially increasing the depth of field. Now since when the aperture is small, even the background will be in focus. And that is all about the bokeh effect. I hope you learned something from this one.